Next, we're going to talk about subsets. A subset is a set that has all of its elements in, well, another set. You always have to have two sets to talk about a subset relationship. So A is a subset of B if everything that is in A is also in B. So for example, first we have our notation. This is how we have A is a subset of B. For example, I have two sets here. The first one is 1, 2, 3. The second one is 1, 2, 3, 4, 5. Everything in this first set is in this second set. Shows up right there at the beginning. Doesn't need to be at the beginning. It doesn't even need to be all grouped together. As long as everything in this set is also in this set, this subset relationship is true. Here we have the set 45, 76, 101 is a subset of Z, which, if you remember, is the set of all integers. And all three of these numbers are integers, so this relationship is true. Of course, we don't have to work with numbers. There we have the set red, yellow, blue is a subset of red, orange, yellow, green, blue, purple. And here we have two of our number sets from earlier. N was the natural numbers, R is the real numbers. Since every natural number is also a real number, N is a subset of R. And 5 is a subset, well, the set containing 5. Now, this would not be true if this didn't have the curly brackets around the 5. 5 by itself is an element of this set, but you can have a set that only has one thing in it. Sometimes we call that a singleton set. But this is the set containing 5. That's a subset of 1, 2, 3, 4, 5. So, question. Is 5, 6, 7 a subset of 3, 5, 7, 9? And take a second to formulate your answer, and the correct answer is no. The reason I know that it's not is because of this 6 here. Because there is a 6 here, which does not show up in the second set, it is not a subset. So we can put a slash through that subset sign. So, and that was necessary. We needed to find one thing in the first set that was not in the second set. There might be more than one thing in the first set that's not in the second set, but one thing is enough for it to fail. And in order to show that a set is not a subset of another set, you do need to be able to find that one thing. So another question, is the empty set a subset of 3, 5, 7, 9? Well, we need to pause and think. In order to show that it's not a subset, I would have to find something in the empty set that is not in 3, 5, 7, 9. But I can't find anything in the empty set that's not in 3, 5, 7, 9 because I can't find anything in the empty set at all. There's nothing in the empty set to be found. So, yes, kind of by default, the empty set is a subset of 3, 5, 7, 9. And there really wasn't anything special about 3, 5, 7, 9 for this question. I could have used any set as that second set. And it is true that the empty set is a subset of every set. Any set you can think of, the empty set is a subset of it. That will always work. For that same reason, you just can't find anything in the empty set that's not in whatever set you want to talk about, because there's nothing in the empty set at all. And that is enough to finish out the handout. So you should be able to work all of the exercises on your practice with set notation handout. If you have any questions, please post them in the discussion forums.